Okay, so good morning, everybody. My name is Colin Cecil. I'm an IT director at Merck with responsibility for our system retirement and archival program. I'm here with my colleague Baba Patro from Cognizant today to talk to you about a project we undertook in the first half of this year for the retirement of some remaining assets on an IBM Z Cloud mainframe, how we transferred them over to AWS and the capabilities of AWS that we were looking for in a solution, and also how the Cognizant processes and methodologies were able to assist us in the program. Baba?
Thank you, Colin. My name is Baba Patro. I lead a practice in information lifecycle management in the space of data and analytics. Thank you. And thank you, Colin, for being partnering with us on this program. It always amazed me how much in-depth understanding you have on the business problem and situation relevant to Merck, and more than anything, your integrity to work.
Thank you.
Thank you.
And take through the agenda.
We will cover today the Merck's business problem and situation that Colin will first explain. Then we'll go over to the Cognizant's Adaptive Data Foundation, a new offering in the space of data and analytics. Then we'll go over on the solution, what was adopted to solve Merck's problem on the data modernization, and followed by the business benefits that Merck realized.
Okay, so we'll just quickly talk about Merck for a second. For anyone not familiar, Merck is a global life sciences company specializing in human and animal healthcare. We operate in over 140 countries. We've been in business for 125 years, known globally as Merck Sharp and Dome. The driver behind this project is that we had a final IBM Z Cloud mainframe, a very powerful computing asset, very fit for purpose. However, we had migrated the majority of our assets off that, and so we were looking to complete the process and close down the Z Cloud. The challenges here, clearly there was a significant operating cost associated with running a mainframe for the remaining assets that we had running. But additionally, the mainframe is a powerful platform. However, in terms of the analytics and usability and customer interface is not on par with some of the technologies that we have available at this point in time. So we were looking to either retire or archive our remaining assets. And the asset that we'll be talking about today was one that was still under our data retention policy. So we had an obligation, regulatory obligations, to retain the data for an extended period. So we partnered with Cognizant, and we'll talk briefly about how Cognizant went about the retirement process, and then we'll talk about some of the benefits that we gained from that.
Thank you. Cognizant's Adaptive Data Foundation is a new offering in the space of data and analytics. All of us, in some fashion or form, engaged modernizing our companies digitally. This is not new. The digital natives are causing the disruption in the marketplace that we have seen in last few years. Hardly anybody can deny that. At Cognizant, we unravel the patterns in which these digital natives are causing the disruption and threatening well-established firms if they are not catching the bus to get on to the modernizing their landscape, their business operations, they're providing, how they're providing the customer experience. So we unravel that, and that is where comes Cognizant's Adaptive Data Foundation. We see them through 3 building blocks. Every transformation starts with customer. If your insight to customers' experience that you want to generate for, if that is good, you can sustain in the marketplace in a greater way. To deliver to that customer experience, your product and services got to be intelligent. We cannot look at in silos products and services separately, because all they go to the same point of giving to the customer that experience that you promised. And to deliver that experience, your business operation got to be adaptive, responsive, and intelligent. This created the avenue for bringing a reference model, an architecture, overarching architecture that addresses this concern. That is where it comes, Cognizant's Adaptive Data Foundation. So it starts with very three basic principles. Starts with one, responsive data architecture. The pace at which you get the data ingested, consumed, and report has to cover holistic view of the data. The structure, varying structures of data, the data sets, the temporal values, at a pace at which you can consume and you can use for intelligence. That's the first principle that we used in the Adaptive Data Foundation. Second, why, at this time in the industry, people cannot wait for weeks and months to generate a new data insight, a new data set that helps you to create a new data insight. You got to have this intelligence built into your data management to generate, help produce the pace at which you want to bring that insight out. And third, companies like Amazon identifying and producing a new insight at a greater pace, you wouldn't believe, in 11.56 seconds. To stay agile in the marketplace, you need the pace, you need the scale. That is where delivery at scale comes into play, and these are the core principles of Adaptive Data Foundation. You have intelligent data works built on top of these three is a transformation toolkit that Adaptive Data Foundation has it, and it is built on key 19 attributes. We have seen the patterns, and we identified 19 attributes key to address all these three different pillars. Let's contextualize for Amazon Web Service and AWS. The ADF story, the ADF foundations to work, we believe your environment got to be cloud-enabled or cloud-leveraged. That is the first thing that you have to look at it. Second, your compute got to be separate from your storage. It's no more monolithic. Third, your storage that you adopt for handling all the analytics workload got to be containerized. The compute got to be containerized. The storage got to be object storage for your enterprise workloads. To generate the pace, generate the scale, these are the principles you got to adopt at the enterprise level, with the aim at generating the responsive insight at a massive scale. It's not easy. You have a lot of lines of business in your enterprise. It's not easy to generate that insight. But if you adopt these principles at every level of your enterprise, you would be able to get to this point. In this time, no more it is unidirectional of the data flow. I have to consume the data through the reports. It's just one way. It doesn't work anymore. You got to have multi-directional flow of the data, going into the customer experience, bringing the customer experience back into building the modeling work immediately, and then generating the enhanced analytics to support the customer experience. You got to have multi-directional flow built in to your model. And to And fundamentally, at the gate of this thing, you got to have a responsive model underneath all of it. A model that can self-address, self-heal. It got to have those things built in. It is not an add-on. Typically, we do that add-on. We clearly say that we clearly prescribes what not to be add-on the modeling. Let's spend some time, and I will request Colin to talk about it. We used automated data lifecycle management is one of the attributes that I talked about, 19 attributes of adaptive data foundation in the Merck context.
Okay, so part of the challenge we had on this particular project is that the asset had been resident on the mainframe for an extended period of time. We used a portion of the asset, but the entire asset was under our data protection responsibilities. So the first two phases here of the lifecycle management, the discover and the classify, was very important in this instance because we needed, before we could migrate the data and test the migration, we needed to understand what the asset was, how it was being used, and what the retention we needed to apply to it was. So that was a couple of phases that became integral or very critical to our program, was the understanding of this asset and ensuring that as we brought it over, we understood it sufficiently to design a testing methodology that would allow us to prove that we retained the asset and met our retention policies.
On the foundation, how did we achieve that? Everything we built, keeping in mind the delivery at scale. There is a mainframe sitting. Lot of unknowns. What data is to be there, nobody knows. So if you have a people dependency on your discovery, then you are lacking something. You always say, XYZ said, this is what my requirement. You got to hit to the point where what makes this source of truth for any modernization story. So you got to have the intelligence built in how you discover the data, how you classify the data. We classified the data with the intelligence saying, this is all the day, every day you are using, this is category 1. This is potentially to be used in similar reporting fashion, category 2. And there is another set of data, massive data, about 60, 70 terabyte. After doing the dedupe, we found about 70 terabyte of 60 terabyte of data that to be kept for retention compliance. Early discovery, early identification and classification of the data without having any people dependency, directly taking it from the source of truth, from the system, made us the confidence that we have not left anything undiscovered. That is number one. Number two, when we started migrating them and implementing them, building the monitoring process, it's important that how you monitor. Anybody can say that, okay, I have a job, it failed, then I monitor. But bringing that self-adjustment, the job adjusts by itself and tells you, I failed and I fixed it, here is the report. When you do the testing, how exactly you are doing the testing? At every level of bringing the data over and consuming the report requires a different level of insight. And that is where the principles of adaptive data foundation we leveraged here. Next, we will talk about the implementation framework. We talked about the data. They are sitting on virtual tape, age old, could be 30 years. Hardly anybody knows what data is there. The virtual tape is not easily available that you can run a report and get it. And this is the case for most of the legacy systems. And we used different Rex programming to go to the bottom of it and then get the data. And we got about 10,000 plus data volume or data sets that we can say uniquely identifiable that requires an analysis and categorization and make the decision what to be kept and what not to be kept. So the early analysis gave us those window of opportunity. Second, the tape volume was more than 110 terabyte. And you can go through the legacy, you will see those are already compressed. When you uncompress them, it could be 150 terabyte plus. If you would have looked at that gigantic, it would have taken a different way of thinking what to be done to get those data out. Right? So to handle that, the discovery and analysis and also the migration require the scale. When it comes to the testing part, we used well-established GXP compliant sampling methods, and we will talk about it soon. How did we do it in the solution slide? When it comes to the reporting, it was very important that in mainframe you can write 10, 15 jobs to pull a report out. And after 10 years, 15 years, these people are not there. When you go and saying, what do I have to do? It's very hard to reverse engineer those things. But we could do that at the scale at which we can provide these reports in the very fast fashion. We'll also talk about when we talk about the entire solution that we implemented.
Let me just jump in here for 1 second. So one of the more interesting challenges that we faced during this project in the modern world, many times we're becoming very accustomed, or we make assumptions about the availability to move data in a very large, very fast manner. What we discovered is the contracts we had with communication companies and some of the infrastructure that we had in place were not scaled to move the volume of data that we're referring to here. Mainframe data is typically bits and bytes, very small, low volumes. What we had in place had been fit for purpose for decades. But now we're trying to move, as Baba said, nearly 100 terabytes of data. We need to move it fast, and we need to be able to demonstrate control from end to end. And we were looking at multiple options, including introducing new contracts with the telecommunication companies, introducing new hardware both on our side and at IBM. And the time frame to actually set those up was very significant. And then once you've established that, you've then got to move the data. So we ended up with a fairly complex solution whereby we transferred the data off the mainframe onto a IBM mass storage device. We then brought that to the Merck environment, transferred the data off onto a Merck device, and then onto the AWS Snowball, and then shipped it over to Amazon, which sounds an incredibly convoluted and complex and unnecessary process. The challenge was, and it's, when you step back and think about it, understandable, IBM and Amazon both run their own data centers, and they want to ensure security and control in those environments. They don't want to have any unregistered devices located within their data centers. So neither company, understandably, wanted to allow the other company's mass storage device into their environment. So this added the complexity of us actually saying, well, ship it to Merck. We'll then transfer the data between the two devices and move it over. Complex, cumbersome, but it turned out to be a quicker way of actually moving this large volume of data, given the infrastructure we had in place, than trying to improve the infrastructure and deploy that in the time frame we had available.
Thank you. We used primarily three, we call attributes of the adaptive data foundation, primarily three attributes solving Merck's problem here. The automated data lifecycle management, the cloud-enabled architecture at scale, and unified security model. And for every aspect of the attribute, there are framework, there are workbench, there are services, toolkits that we can leverage to deliver at scale.
You ready? This clicker doesn't seem to want to advance. I must be at the wrong angle. There we go.
So what we did was, we implemented these workloads in DevOps. We didn't want to say that finalize the requirement, which is typically the case, finalize the requirement, then we will do it, because it's never ending. Every time you speak to a new person, you will get different understanding of what data to be archived, what data to be modernized. And we created the DevOps in a way, every data ingested goes through the migration process, goes to the validation, goes to the functional validation of reporting, that it enables the reporting. So we run through these things in multiple chunks, and it can almost like a self-cycle, self-oiled engine for every chunk. The moment one comes in a data set, how does it go through this life cycle until the user report being generated? We will talk about the data migration followed by the validation principles and how did we validate, and then we will also talk about the user experience and the reporting. This is very complex, what you see, but the essence of it is that at every integration point, we looked at it how to build in the elasticity at large. What do I mean that? If we adapt a snowball, and snowball comes out, after a week you realize certain amount data is still there. You have to send another snowball. It's not going to be an easy cycle. You got to find out for bulk migration, snowball. For the other ones, which is the peripheral data that you discover until almost to the end of this program, you should have an elasticity built in. How do you want to make the data over? And that was, we kept it in mind that a certain amount of data that is being consumed through reports, we will bring it without having the bulk appliances that we brought in towards the end of the program. That it wasn't an easy conversation like but like Colin mentioned about it. It wasn't easy. There are certain things that you would also come across when you do a legacy modernization. These mass storage migration devices are built to take the data into the cloud data center. They are not built to take the data off your cloud data center. We experienced that issue. We went through almost 2 months of churning process before they could reconfigure this bulk device to take the data off of their data center. And those are the experiences we will talk about shortly. While those things going on, we didn't wait. We got the data over, we created these reports, this business started building the confidence, yes, we are able to see the report, so end of the day, they have to give sign off that mainframe can be shut down. So we built elasticity at every integration point to generate the migration at scale.
Yeah, so a couple of things to add there. As Baba mentioned, the challenge of, particularly for IBM, their devices were configured to bring data into their data center, not take it out. Took some time, and fortunately, even if the pipes that we had available to us were not large enough to move the data, it allowed us to get a portion of the data over, which allowed us to construct the tests and the reports and be working with the business. I'm sure many of you immediately saw the more interesting part of this slide, buried in there. One of the challenges we faced is that the data in the IBM world is in EBCDIC format. The data in the S3 world is in ASCII. So one of our basic opportunities for testing is obviously to say, do you have the list of files on both sides, and are they the same size? And maybe run some checksums so you can demonstrate confidence that you've brought the data over in its entirety. We couldn't do that because we had to transform the data in a fundamental way during the transfer process, which eliminated any byte counts, checksums, and other basic testing configurations. So what we were looking to do was we did the byte size counts, but we could only do it from the IBM Z Cloud until the cluster of 3 colors in the middle, where we transformed it from EBCDIC to ASCII. So we then had to conduct testing to show integrity of the data in terms of record count, field counts, as we moved from the EBCDIC format into the ASCII format. And then to conclude, as we'll talk about in the validation, we went ahead and took some of our experience in our manufacturing process, and we actually designed and implemented programs that would extract sample data on the Z Cloud side, extract the same data from the same locations in the files on the Amazon side, and then we utilized testing protocols to actually confirm 100% those fields and records were the same. So we had to go into a more complex testing methodology than we would normally get into because of this transformation of the data, which took out some of our fundamental testing capabilities.
So we use the ANSI standard, which is very standard for the drug manufacturing industry. And sometime and very often what we do is when the massive data to be ingested or transformed for any transformation program, you would say, okay, I will pick up 1,000 records at the beginning of the file, but that wasn't sufficient enough for the industry of GXP compliant industry. So we had to pick records in the beginning of the file, end of the file, middle of the file, and do the comparison at scale that can say that these are the records were off or these are the records were not off during the migration process. And that is equally applicable for any modernization large programs if you are dealing with a strict regulation like GXP compliance regulation industry. We used Amazon has a very native reporting capability, Athena. We use the Athena. First, we used the glue to understand the metadata of the structure. Then we used the Athena for reporting. And so about 100 to 150 GB data, it brings to each queries and generates the report in 10, 12, 15 seconds. That was not their earlier experience business used to have on the legacy. They have to wait for the program, the job to run and schedule and all that. Here is real-time access to your large data set and get the volume. They don't even realize to what volume they are running these reports because immediately the report comes in. We have to create in a certain ways this data to be created in the design for the reporting performance. So we use something called partitioning even in S3. So there is not many people doing it, but these are the principles that we looked at it. You have to have this performance built in when you are designing it for large scale dealing here. So we use the partitioning of this 60, 70 terabyte of data, and it still generates the report in 10, 15 seconds, and the user was so happy about it. Also, we enabled the service calling approach to your Athena reports, so you can always get the same report through any service calls.
Okay, so concluding here, some key challenges and learnings that we had. As with many assets that have existed for a long period of time, the knowledge of the asset had diminished, the knowledge of what the structures were, how to use it, the capabilities. So the subject matter experts' availability was limited, and we had to do a lot of analysis at the beginning of the process in order to really understand what the asset was and what our obligations were. Touching on obligations, in Merck working in a regulated industry, we have our data retention policies, so that constricted our ability to just wipe out the data. This was something that's still retained under our regulations, and we have to design for that life cycle. We mentioned the challenges, the 2 cloud services, and yes, it's fine if you want to move data in a small volume, but when we're dealing with the many terabytes, this presented a significant challenge, as we've touched on, and we kind of backed ourselves into a corner with the time frame. This was our final asset on the mainframe. It was a large one that took a long time to move, and obviously with the mainframe, a very powerful platform, but also a very costly platform. So the clock was running, or the meter was running, while we were doing this work to try and shut the system down in time.
On the key learnings that we got from this program implementation at Merck, whenever we deal with a compliance relevant data sets in a massive scale, you have to have early analysis of the data so you can understand what is the rot data, redundant, obsolete, and temporary. It's easy to say all the data, and business always will say all the data I need, until you prove them what is the duplicate, and it has to be the model in which you prove them has to be defensible. And that is built into your automated data lifecycle management attribute of adaptive data foundation. The second, your testing cycle has to be AI driven. How you drive your testing and validation at a different level of testing. Some could be technical testing, some could be functional testing, some could be non-functional requirement testing, and all these things has to be AI based, self-adjusting to certain benchmark that you establish. From the security and compliance protocols, whatever solution that you built in, how do you ensure the amount of data that you expose and what data to be purged and what data to be kept for retention compliance is very important to establish that design framework at the beginning of your implementation. And third, the network latency and the bandwidth always will be challenged whenever we deal with the legacy modernization. When the legacy modernization, let's say 5 years ago when the G Cloud was established at Merck, it was a good selling point. You don't need a 10 TB line established with your G Cloud, you need only 15 Mbps, 14 Mbps line. That is good enough to get the data from mainframe. But when we do this kind of use case to get all the data, it could be 100 terabyte, for another situation it could be in petabyte. So the network bandwidth always will be challenged, and that shouldn't block but the scale. You can always find how do you achieve it. Right now we have a lot of mass storage migration devices available, and they are well established, certified for your compliance reasons as well. And the other point which is very important is, even in AWS context, compression is available. When an Athena-like reports and Glue-like tools, their cost is based on the usage, the data scan, how much amount of scan data that you are scanning. We compress the source data, so the scanning cost is based on the compressed volume. So even though let's say we ended up keeping 60 terabyte, it was, well, I think less than 30, 35 terabyte on the storage point of view. So S3 cost was optimized, Athena cost was optimized, Glue cost was optimized as well. And these features are available in AWS.
So finally, the business benefits. Clearly, we achieved a reduced operating cost. We did meet our timeline, fortunately. It was tight by the end, but we got there. As Baba mentioned, the business community experienced significant increases in their performance and their data access capabilities. We retained our current security models, so obviously implemented in a different manner, but the same user roles and groups we were able to replicate across the two environments and meet, therefore, our compliance obligations. And the Athena came with far superior business analytic capabilities and putting power into the hands of the business to access the data rather than relying on the development of specific reports from the IT community.
To summarize, to wrap up this session, of course, Adaptive Data Foundation provides you tons of workbenches, toolkits, frameworks. But let me put these questions to you. For your modernization program, before you embark on it, 3 fundamental key questions you should ask yourself. These are must-ask and must-answer questions for your transformation programs. Is your data foundation that you're trying to establish, is it adaptive? Are you clear on what business outcome you want to deliver? That's the first question that you should ask. Are you clear what business outcome you want to deliver? Second, say you are clear on that. Is your data intelligent enough? An Adaptive Data Foundation has a tool that tells you what is the IQ of your data. And third, how many business processes in your enterprise, in your organization, are truly using embedded insight? And Many of these data lake programs in last, let's say, 5 years are falling short of the expectation. The reason is missing purpose. You implement it, and then so what? What is next? The purpose is missing. So you got to ask these 3 questions and answer them very clearly. What do you want to achieve it? Yeah?
Okay, so that concludes what we wanted to cover. If there are any questions, we're happy to take them.
So for ingestion, did you consider anything else apart from Snowball? Did you consider any other products or any other ingestion frameworks?
So the question, I think, is did we consider anything other than Snowball for ingesting the data into S3 or into another platform?
In your architecture, right?
So we did look at other methodologies. We looked at the ability to move the data through different more high-speed pipes. But ultimately, in order to load the data into Snowball, we need to have a piece of hardware that Amazon is going to allow into its data centers. And so the Snowball was the one that was authorized, so that became the de facto solution in this case. And the question became, how do we move the data onto the Snowball as quickly as possible? Does that answer the question?
Even just to add to what Colin mentioned, even we said you have a mainframe and G-Cloud, that is where the data was. Can we have a file server connected to your mainframe so we can dump the data and bring it over? But understand these things all built in from economical standpoint. There is these mainframe racks does not have sockets to connect a distributed mid-range server. So the answer was no. So you cannot connect any other mid-range server to a mainframe rack. So the data center doesn't even allow it to do it.
And again, it's what would IBM, not only what can be connected, but what does IBM allow into its data center for the security and protection reasons. If we missed anything, I'd be fascinated to know any ideas you have, but we had to deal with what we had in front of us.
You also had a product called Cransoft, right?
Yes, Cransoft is a third-party software. Back Office Associates produces it. We've been using Cransoft as a data movement and validation tool as part of our SAP implementation for 10 years, 10, 15 years now, 10 years, getting ahead of myself. And so when we were looking for a piece of software that could compare files, and in this case the sample files we'd extracted from the 2 sides, we talked with our testing team and they recommended the Cransoft utility, and that worked very well. Cransoft could have compared the entire data set side by side and done 100% comparison of the entire files, but then you get into the problem of how do you move those entire data sets to the testing software. So we just settled for moving the sample files.
You also mentioned some learning. You mentioned network and latency as one of the key learnings. So what are the issues that you encountered?
So I'm not a network guy by any means. My understanding is that we were only achieving 20 to 25% of the theoretical capability of our bandwidth between the IBM data center and the Merck data center. So even though we could have forecast perhaps we could have moved the data in 2 weeks, 3 weeks, had everything been perfect, when we were encountering the actual performance, we were seeing a far longer and extended period of time to move the data. I don't know, Baba, whether you can add anything to that?
No, I think you.
There was no concern moving the data to AWS and serving the data from AWS, right? So you had concerns moving the data from IBM data center to the other data center that you had?
Well, Merck has a very large connection into AWS, so we were relatively confident that we could move the data. But even with a large bandwidth, to move 100 terabytes of data, once we had the availability of a Snowball, it was still quicker to actually just load it onto the Snowball and ship it. Plus, we didn't want to get in a situation where we were chewing up the bandwidth and causing any performance issues through other Merck services going up against AWS. So the primary concern was in the connection from the IBM mainframe into the Merck data center. It was fit for purpose, but we were trying to use it for a different purpose at this point. Okay, thank you very much.
Thank you very much.
Oh, we have one more question, sorry.
Hi, Colin. Vikas here.
Hi.
Do you have any, thanks for sharing this. This was very wonderful, insightful. Do you have any suggestions for any of our implementers of the pitfalls that we should avoid? Any big pitfall or big advice that we should take care of while going on this journey?
Now, I think from the key element for me that allowed us to accelerate this cycle was quickly getting to a point where we understood what those legacy assets were, not just they're a collection of files, but what were their purposes, so that we could instill confidence in our business counterparts that the reports that we were designing were fit for purpose. Ensuring we had a robust testing protocol that again gave the business confidence that we could show that, yes, we've not looked at every bit in this and every field, but we've done sufficient sample testing to ensure that we've delivered the solution. And ensuring that you've got a clear movement of data. This was something that caught us by surprise time and time again as to how complicated it became to actually ship data. I'm just used to plug it in and move the data. This was just the volume of data, and the legacy connections became a challenge for us.
Just to add one other item that comes to my mind is whenever you have an established network with a cloud partner, lot of other third-party dependency comes into play. Example, AT&T contract could be there with a cloud partner. So you might say, hey, I'm done with my job. Next month, I'm off the contract. No, there is a dependency clause that with their service provider, with the cloud, is built into your heads up that SLA that you have to give it to them. So when you program, when you timeline your program, you have to keep in mind what are the other peripheral contracts this cloud party has it. Accordingly, that establish a time frame for you.
Thank you.
Yep. So, I mean, the question is, how else are we using this data for other business intelligence purposes? At this point in time, the data was not being actively used for other purposes, and I think for the most part, we have equivalent or even potentially better data sources available to us through other protocols. But we have a data retention policy. We'd made business decisions related to this that we may potentially have to explain to external authorities, and so we needed to ensure that we could retain this data set, even if the value of it perhaps is not what it was when we purchased it. It was more, Merck has retention policies, and we always meet those policies. So sometimes we do things for where there may not be a huge amount of value, but we're obligated to do so. Okay, well, thank you, everyone.
Thank you.